A tool that indexes a large code base might take 2 minutes. A tool that processes a video might take 10. If you just block the connection until the tool finishes, the user sees nothing. The host may time out, and there is no way to cancel. MCP has a notification system designed exactly for this. In this episode, we build tools that send progress events while they run, and a client that displays live updates as they arrive. MCP notifications are one-way messages from server to client that require no response. They use the same JSON RPC format as other messages, but have no ID field. The notification/progress method carries 4 fields: a progress token that links the notification to the original tool call, a progress value representing current completion, a total value representing the expected maximum, and an optional message string describing what the tool is currently doing. The client accumulates these, and the final result arrives separately. To enable progress notifications, the client passes a progress token in the _meta field of the tool call parameters. The token is a string that the client chooses and the server echoes back in every progress notification it sends. This links each notification to the correct outstanding tool call. After sending the call, we enter a read loop that consumes notifications until the final result arrives. The notification reader loops continuously reading messages from the server. If a message has a method field, it is a notification. We check for notifications/progress and call the optional onProgress callback with the current value, total, and message string. If a message has a result or error field, it is the final response, and we break the loop. The onProgress callback lets the caller render a progress bar, print to the terminal, or update a web UI without the reader needing to know anything about the display layer. On the server side, the tool handler receives a context object alongside the name and arguments. The context carries the progress token from the client request. After each unit of work, we call ctx.reportProgress with the current position, the total count, and a descriptive message. The MCP SDK handles formatting and sending the notification message. The tool continues working, and the client receives a stream of progress events with no extra threading or queuing needed. The show progress callback renders a terminal progress bar using block characters. We write to standard output using a carriage return rather than a new line. So, each update overwrites the previous line. The bar fills proportionally based on current divided by total. Passing this callback to call tool with progress means the user sees a live updating bar in the terminal as the codebase indexer works through each file. No threads, no queues, just an async callback triggered by each notification. For long-running tools, you should always set a client-side timeout. We wrap the call in async io.waitFor with a configurable timeout. If it expires, we send a notification/canceled message to the server with a progress token as the request ID. Well-behaved servers listen for cancellation notifications and stop their work gracefully. We then raise a timeout error to the caller so the agentic loop can handle it, either by retrying with a longer timeout or by informing the user. You now know how to send progress notifications from a long-running tool. Read them on the client side with a live progress callback. Render a terminal progress bar, and handle timeouts with a graceful cancellation notification. In the next episode, we connect our MCP server to the RAG pipeline from the first series, a tool that retrieves relevant document chunks and returns them as context for the model. Subscribe so you do not miss it. See you in the next one.